Okay, so today we're doing Unit 8, Day 2, Properties of Parallelograms. Let's start off with the properties. Again, key thing here is the word parallel for parallelograms. Okay, opposite sides are parallel. Okay, so that's the first thing. Next thing, opposite sides are congruent. Third thing, opposite angles are congruent. Fourth property is that consecutive angles are supplementary. And then the fifth and final thing is that diagonals bisect each other. Okay, let's play with this a little bit and let's see how these properties work. Okay, so it says each quadrilateral is a parallelogram. Find the missing measures. Okay, so I'm going to look at what they give me first. So I know opposite sides are congruent, so I know that this is 15, I know this is 8, and then I know that opposite angles are congruent, so this is going to be 68, okay? Remember, also too, consecutive angles, or angles that follow each other, those add up to 180. So you go 180 minus the 68, okay, that's where you're going to get your 112 right there, okay? So we now know everything. AD is 8, DC is 15, the measure of angle A is 112, the measure of angle B is 68, the measure of angle C is 112, okay? Next thing. Alright, so let's see what we've got, okay? Keep in mind they say that RT equals 30. So RT equals 30, well, that is a diagonals, and diagonals bisect each other. So you know that this is cut in half, and this is cut in half, okay? So right off the bat, if that whole thing is 30, I'm going to put 15 there. 15, okay? So that's 15. I'm going to zoom in a little bit, okay? And then what else do we have? We have, this is obviously going to be 27, this is 18, okay? Alright, so we've got UT is 27, that was easy, ST is 18, VS is 7, so sorry, and then VT is 15, okay? Alright, let's go on to a bigger example. Alright, so number 3, it says given XY is 15, XY is 15, okay, so we put that in. WX is 22, ZX is 52, ZX is 52, so that whole thing is 52. Well, I want to split that in half, so I'm going to go 52 divided by 2, that's going to be 26, so right here, this is 26, that's 26, okay, and then WT is 23, right here, so I know this is also 23, WZY is 72, WZY is 72, so W to ZY, that whole thing, okay, so right here, I'm going to write 72 degrees, so I know this whole thing right here, that's also 72 degrees, okay, and then, because consecutive angles, right, you have to subtract 180 minus 72, that's going to be 108, so right here, this whole big Y is 108, and that is 108, okay? So again, I'm not playing with these, I'm looking to see what I can solve first, okay? All right. So we've got ZW is 15, ZY is 22, TX is 26, WY is 46, angle TZY is 67, XYZ is 57, XWT is 22, XYT is 67. Okay. One thing I forgot to mention is that they also gave you that WX to T, this little puppy in here, is 35. Okay. So because of alternate interior angles, this is also going to be 35. Okay. All right. And then this right here, ZWT is 59. Let's throw that in there. ZWT is 59. That's right here. So this little bitty angle is 59. If things get too busy, you must draw a bigger parallelogram. Okay. So here we go. Let's finish this. If this whole thing is 108 and they gave you that as 59, you go 108 minus 59. So that's going to be 49. So I'm going to put this 49. And this is going to be 49 in here. And then now, if this whole thing is 72 and that little angle is 35, you're going to go 72 minus 35, so you're going to get 37. So 37 goes in here because of alternate interior angles. 37 is going to go in there. Okay? Alrighty. Now, I want you guys to do number 4 and number 5. Okay? So do those. For number 6, TV is equal to 74 and WV equals 4x plus 1. It says solve for x. The biggest thing is to keep in mind that 2 times WV, right, is equal to TV. Right? So let's just plug those in. 2 times 4x plus 1 equals 74. Right? So now you've got 8x plus 2 equals 74. Alright? And then when you get rid of the 2, 8x is going to be 72. And then you divide both by 8, x is going to be 9. Okay? Alright, let's do the next page. So right here, proving parallelograms in the coordinate plane. Okay? So coordinate plane, you know you're going to be dealing with coordinates, right? Alright, so here's one method, okay? Both pairs of opposite sides are congruent. So you're proving that this side is congruent to that side. AB is congruent to CD, okay? And then you're proving that this side is congruent to that side. AD is congruent to BC. Then ABCD is a parallelogram, so you're going to use the distance formula. Use distance, okay? Here, you're going to prove both pairs of opposite sides are parallel. Well, you can only prove things parallel by using slope, okay? So, you got to prove this to be parallel to that, AB parallel to CD, and AD parallel to BC. Okay, so again, you're going to use slope to prove things parallel. Now, when you have to prove one pair of opposite sides to be congruent and parallel, you use slope and distance. Okay, so I'm just going to pick AB and CD. You want to have them be congruent. So if AB is congruent to CD, okay, and then if AB is also parallel to CD, then the ABCD is a parallelogram. Okay, so you're going to use these formulas. Let's do a couple together, and then you could do one on your own. All right, so this one. determine whether the figure is a parallelogram using the distance formula. All right, so again, you want to draw out your parallelogram. Go clockwise. Okay, so you want to prove that this is congruent to that and this is congruent to that. All right, let's do this. So let's compare AB to CD. AB, you're going to have 1 minus negative 7 squared plus 2 minus 4 squared. That's approximately 8.2. Now, let's compare CD. You have 1 minus 9 squared plus negative 6 plus 8 squared, and that is also 8.2. So these two sides are congruent. Okay, so we've got that. Now let's look at the other one. Let's look at BC. So BC is 9 minus 1 squared plus negative 8 minus 2 squared equals 12.8. All right, so this is that. Let's compare that to AD. AD is 1 minus negative 7 squared plus negative 6 minus 4 squared. That gives you 12.8. So we are congruent. Okay, so yes, it's a parallelogram. Okay, let's do one more. All right, so number 2, determine whether the figure is a parallelogram using the slope formula. Okay, so again, I'm going to draw it. W, X, Y, Z. Okay. All right, so first let's compare WX right here to ZY. So the slope of WX is negative 6 plus 4 over 1 minus negative 7, and you put that in your calculator and you're going to get negative 1/4. Okay? All right. Then you compare that to ZY. The slope of ZY equal to negative 12 minus negative 13 over 1 minus 5. That also gives you negative 1/4. Okay, so now we know that WX is parallel to ZY. Okay, so now let's compare the other side. The slope of XY equal to negative 13 plus 6 over 5 minus 1. Okay, so that is going to be negative 7 over 4. Now let's compare that to the slope of WZ. So that's going to be negative 12 plus 4, 1 minus negative 7. That's going to give you negative 1. These two are not the same, so they are not parallel. So we say that not parallel, therefore not a parallelogram. Okay? So let's do number 3 on your own. Okay? See you in class.